Hello, hello. Checking my audio is working? Yes. Well, it most likely is. My microphone is doing the little signal thing, so we're probably okay. Hello, Dong. Hello, Haljan. Um, I don't know if Dong's actually here, or he just wrote first at some point in the past. Actually, now I think about it, not even sure if Dong is a he. I should actually confirm that before saying that. But anyway, hello, friends. How are we all going? I guess I started a little early. I should wait to see if people are turning up. I only just pinged the Discord about it as well. So we'll see how it goes. Had a bit of an early start at work today as well, so I'm a little hazy. But I think what I'm going to do is continue some of the stuff that I was talking about on the Godot engine and learn a bit more about it. I should actually find. I didn't keep the tab open, so I should find out where I was up to previously. Let me switch back to something where you can see my screen. It was in their docs, right? Learn to code with Godot script. With their super cool app. Is my face blocking stuff? No, it's okay. Ooh, it says continue. I wonder if it can save where it's up to. Has cookies, maybe. Defining your own variables. Okay, cool. This is probably where I was up to. Right. I don't know. Oh yeah, I think it was right because they did functions before variables, which we found quite interesting. But it turned out to actually kind of make a lot of sense in terms of how much you need to learn at each point in time. So that kind of works out. I wonder if there's anything else I wanted to talk about before we dive into it. Maybe not. Maybe let's just dive into it, and I will. We'll hang around and chat if other people turn up. But otherwise, I'm just going to keep kind of going through this. But I might skip some things because I feel like all I need is a bit of the syntax and or a bit of like like example code to copy and stuff like that, and I should have a handle on what's going on. So let me have a look at. Okay, errors, yes. Adding and subtracting. I think variables adding and subtracting, I don't think that that's likely to be something we're going to have problems with. Game loop and time delta and stuff like that, maybe this is where I skip to for now. Show and hide functions for visibility. Process function. So they've got an issue with their colors there. I used to do this. Did you know when I was teaching coding, when I was teaching 1511, and I had just had Google Slides, Google Slides didn't actually have code syntax highlighting in anything in their text. So I was actually highlighting and changing colors of things manually on code samples. It's just lucky that I was doing a such an early part of a language that I was writing so little code that I could just hand syntax highlight it. But it was a bit meticulous. It was a bit unnecessary. Haljan is officially on holidays. You finished everything for term 1. Congrats. I hope you're taking some time to chill. I'd assume that most people have finished their exams now. I'm not really keeping up with where everyone is at university, but I assume that term one has finished. When are you going back to semesters? It's not this year, right? It couldn't be. I assume it'd be like next year or the year after. I think it's always funny things when you say that the university's changing to XYZ, and like half the students there are like, this means nothing to me. I'll never see it. Because if it doesn't happen within 3 years, it's basically not happening for most people. Okay, let's have a look at this. Process function gets its name because it does calculations or continuous actions. It's like a juice factory that processes juice bottles. Okay, this is an interesting um metaphor. Bottles are always moving along a conveyor belt while different machines operate on. Okay, that's cool. I do like that idea of like the frames keep coming and you do the same thing to each frame. Function can run hundreds of times a second, so we're talking about frames. 2028. Oh wow, that's ages away. I think the introduction of trimesters was quicker than 3 years. Oh, less than a week left of exams, so there's still some people in exams. Okay, how many parameters does this function take? It takes one, the delta. Process function won't do anything until we add something to it. Notice the underscore in front of the function name. Convention program is used to coordinate work, and it'll only make sense once you have experience coding in Godot. Yeah, I don't really know this convention, so I don't think I've ever worked in something where there were specific functions that you were like tagging with this underscore beforehand. When you use knows the function exists in your code, it's called precisely underscore process. Then Godot will automatically run it every frame. Cool. Okay, so this is our kind of frame loop. Update function, I think, in OpenGL and other things. When Godot draws on the screen, we call that a frame. Is this the same for other engines? Yes, it is. But yes, update. Yeah, I don't know about the underscore. I feel like when I was using Unity, there wasn't an underscore. Maybe Unreal had it or something. Anyway, so every frame we're rotating 0.05 of a radian. So we have frame-based animation now. Cool. Halden saying, the idea of special language things that have a name you're not allowed to replicate is not too foreign though. Like underscore name underscore in Python. Yeah. I think that this language is very Python-y. Because I don't know that much Python. I know enough to have used it a bit, but not enough to know like all the little ins and outs. Okay, every frame Godot will run the process function. Okay, we're getting this idea now. I guess it's kind of funny because it's like I could go through and learn all this, but I'm like, yeah, game loop, let's go. Okay, so we're gonna rotate. Yes. How often does process function run? Lots of times a second. Good. Learn how to process function. Okay. Make the robot rotate slowly by adding to the process function. Rotation speed of about 0.05 each frame should do. Okay, so was rotate a reserved function? I don't think it was. It's just called rotate. All right, so we're just replicating what they did. Nice. Make the robot move in a large circle slowly by rotating it and simultaneously moving it along its X direction. Add rotate and move local. Move local. Right, so we're getting to this idea that everything can exist in its own coordinate space. So if this thing rotates, its own x-axis is like sticking out of the right of it. So if we turn it, its x-axis could go down or across and things like that. So if we're moving it on its local x-axis, it's not always just going to be going across the screen. I think later on they'll probably go into more detail about things like object hierarchies and how they're anchored to each other and stuff like that. Well, maybe. Probably not in this particular thing, but the kind of thing we'll use in the future. All right. It's rotating and moving to its right. Cool. All right. So we learned about time delta. Almost everything in the game has a process function. Yeah, that makes sense. Everything gets updated every frame. Dozens of times per second, Godot runs every process function in the game to update the game world. Okay, good. I like the way they're teaching this as well, because they're kind of like showing all of the kind of fundamentals of what makes a real-time game. After that, displays an image of the game world on the screen. We call that image a frame. Godot then moves on to calculating the next frame. Okay, good. Fundamentals of games, of the infrastructure that makes games work. Yeah. Again, I go back to this tutorial being an amazing way to learn. I'm going to try to remember this now so that if someone says, I want to learn how to make computer games and I don't know anything, but I want to learn how to code computer games, this is actually a really good way to get started. Because it's hand-holding at the perfect rate by the looks of it. Dozens of times per second, you get the illusion of movement. Yes, how traditional animation works. This sounds like frames per second. It does indeed. Games often run at 60. Means everything in the game updates 60 times a second. Yes, awesome. Let's look at the process function in more detail. What parameters does the process function take? Parameter is delta. Frames take varying amounts of time to calculate. Oh, yeah. Now we're going to be, like, talk about not doing things in specific amounts per frame, but instead in delta, which is the amount of time it took to process a frame. Okay, process function receives delta parameter. Delta represents a time difference. Time passed since the previous frame in seconds. We can use it to ensure that the changes between frames don't make the game's behavior unreliable. This is how we get smooth, time-based animation instead of frame-based animation. Different computers run differently, so a fast computer will have more frames per second than a slow computer. If we ignore delta, the game experience will vary depending on the computer. I like it. They're explaining everything really well. What do we know about delta? It's a value in seconds. Is it in seconds? Do they say it's in seconds? Milliseconds? Like, I assume it's in fractions of seconds, but they didn't specify that. Let's try it. If I'm wrong, I learned something. It varies each frame. Yes. It's the time Godot took to complete the previous frame. Yes. All right, cool. Okay, so it's in seconds. So it's going to be some fraction. And that's good, because then you can just multiply by the speed per second that you want things to happen. Delta you get in processes time difference in seconds. It will generally be a tiny decimal number. Yes. Apply delta, you multiply your speed values by it. It's nice. So that way, this says we're going 3 radians per second. So it should do a full rotation in just under a second. Wait. 2 pi radians, so 3 seconds to a full rotation. Yeah, that's about right. Yes. Okay, good. When multiplying by delta, you make the motion time dependent rather than frame dependent. Oh, nice. That's exactly what I said. That's beautiful. All right, we are in agreement, Godot. Actually, the more I fiddle with this engine, the more I kind of think that this will be a pretty good one to use. But we need to actually get to the game engine side of it before I kind of like throw in. But so far, everything that I've seen in this engine makes me want to use it. So it's so funny. It's just having a really nice tutorial. It's like, okay, I'll use you. I mean, I have kind of intentionally not checked Unity and Unreal, like the big famous ones. So it's kind of like, I don't know whether I'm kind of intentionally going for the smaller one. I don't know if Godot is still indie, but it feels indie. So if I'm doing the smaller indie one, it kind of feels good. All right. Bottom robot moves at a constant distance every frame without taking delta into account and move faster, slower than the top robot on your computer. The bottom robot will move differently for everyone. Okay, so this one is just based on my computer, and this one is delta time. Right. So whatever it is, my computer's going at a lower frame rate than whatever the ideal is with the delta. But this is cool because this demo would work differently depending on whatever computer you're using it on. And whatever, like, if you're G-Synced or something like that, like what's the frame rate of your actual monitor and stuff like that, so they can really screw with things. Okay, multiplying time-sensitive values by delta makes them time-dependent rather than frame-dependent. What does this mean? Rotation speed times delta. We are dividing delta by... Nope. We're multiplying rotation speed by delta. Okay, this wasn't the best question. Because all this is just talking about the math symbol, not about the understanding of these things. But anyway. In the next practice, we use delta to make rotation time-dependent. Cool. Okay. Rotate 2. At the moment, rotation of the robot is frame-dependent. Add delta to make rotational speed time-dependent. 2 radians per second. Okay. 2 times delta should be rotate delta time per frame. This should be fine. They're taking their time to check to make sure it's rotating at a specific speed. Okay, in this practice, make the robot move in a smooth circle using delta. So it's going to be the same rotation and movement, I assume. Okay, this movement should rotate 2 radians per second. Rotate 2 radians per second is 2 times delta. And move 100 pixels per second. Okay, so I assume we're using the same move local. Yeah, all right. Ooh, move local X takes in a delta and a scaled bool equals false. What does that mean? Applies a local transition as x-axis based on the node's process delta. If scaled is false, normalizes the movement. Oh, okay. So we just make that true. And this is the movement, which is delta times by 100 pixels a second. I assume, after reading this, that I have this correct, but we'll see. All right. Yep, that's correct. Okay, so the interesting thing was they just like changed the... I guess they changed which overload I was using here, and with the true. Although I want to check. Oh no, reset. reset my code. That's all right. I hadn't written that much, but let's not press that reset button ever again. I just wanted to edit that true out and see if it was taking default variable values, because this is bool equals false, so it looks like a default. So what was I doing? 2 radians per second. And then was it move local? Move local X? Yes. All right, let's see if this runs without needing the extra variable. Okay. So with the defaults, you don't have to have a second variable unless you actually want to change something. Good. Okay. Take a look at this example. Process delta, rotate 4 times delta. What does the number 4 mean? Yeah, it's kind of the speed that it rotates. Yeah. We can guess what a number represents by looking at the function names, but it's harder to recall what this number does by quickly looking at the code. We've seen how different functions have their own names. Using these names communicates to developers what the functions do. Rotate 2 radians, move local, yeah. We can also assign labels to numbers to help us remember what they do. We call those variables. It's interesting how they're using this word labels. So when they're talking about a variable, they talk about it like it's a label, and then it has a value. And that's a really interesting way of thinking about it. So the variable name itself is a label, and you don't talk about the variable like it has a value. It has a variable attached to it, but the variable itself is called a label. I wonder if that's a better way of thinking about variables, because it kind of puts it in your head that they're just attached to something. They're not necessarily a whatchamacallit. They don't necessarily have a value in and of themselves. They're just attached to memory somewhere. A variable is a label for a value we can save, change, and read later. So it's kind of cool when you think about it. Because in the back end, a variable is just a memory address. So yeah, it is a label in a sense. Hello, Mr. Mango 303. Oh, you had me for Comp 1511 in 2021. And you're keen to see me looking at Godot. Awesome. Oh, you made a few games in it. Ooh, great game engine. Awesome, awesome. Well, it'll be interesting to see. Hopefully I'm going to poke a little further into this today. And I do still have like more than an hour and a half, so hopefully I get to the point where we're actually in engine and working with game example stuff. Alvin says it works well for the Python-y vibes if they're also doing referencey stuff. Yeah. So this label, variable as a label, kind of makes sense. Okay, you can define a variable, yes. Improve the first example, make it clear what the number 4 does. Yeah, this is good. So we're not going to use magic numbers. We're going to have actual variable names. Process delta, rotate by angular speed by delta. Well, it's interesting the variable's outside the function. I'm so used to things where the function defines its own kind of local state. And you don't generally have floating global variables like that. Okay, this line defines the angular speed variable. That makes sense. Okay, if we define... Oh, right, they're about to talk about it. Did I say state? I meant scope. You can tell that I'm just kind of a little tired today. Hi, Zero. How's it going? Okay, if we define variables outside of functions, we can reuse them in different functions. Okay, so we're talking variables outside of functions are global. Values being global by default is scary. Oh, you came at a good time. So at least what they're saying here is that if you declare them outside of functions, but because any function can use variables we define outside of them, we call these variables script-wide. So instead of calling it global, they're calling it script-wide. So I'm assuming that one page of code to them is a script. Here we use the angular speed script-wide variable in both the process function and the set angular speed function. Right. So you can globally change it. And then, yeah, so they're recording that value globally. I'd assume they're recording it globally at this point in time because they haven't defined objects. And I'm assuming that because they did talk about object-oriented, I assume that the thing that's going to be rotating has its own angular speed, like, struct. It will be like kind of like a struct or a class, and inside it, it'll have a property for angular speed. But because that's a complicated concept they can't show at this point, they're probably just going to use the global variable for now, and then maybe not use it later. And they do talk about this here. Mr. Meng saying most of the code is defined in nodes, class. Yeah, right. I thought it might be. So most of the time they're in classes. It's more like properties in object-oriented programming than global variables. Yeah. So, but I think they're also just trying to demonstrate this here, where if the variable only exists inside the scope of the function, this other function can't access it because this doesn't exist outside of this tiny scope here. Good. Okay. The nice thing about this is kind of everything that I'm seeing instantly makes sense to me. So what they've done is they've created this Godot script thing. They've made it look a lot like Python, and they've made it feel very familiar to someone that already knows how to code. So I feel very comfortable here, and it feels like something that would be intuitive to code in. Okay, why this happens, can't use. Okay, let's not worry too much about that, but scoping exists. That's fine. Where can we define variables? Select all that apply. Yes, we can do either inside or outside of functions. And yeah, it's going to be that kind of thing where I'm going to feel like any variable that is declared in open space is going to feel wrong. And I think they're kind of getting to that idea when they're showing this, because they're going to use it like either limited scope inside the function or attached to an object, I assume, once we get deeper into it. Variables also great at grouping values, control how a character behaves. Variables for movement or combat, right? I assume these are going to be, as you're saying, nodes. They're going to be properties of the nodes, but we'll get there. Okay, I wonder if I need to do this. Let's skip to, I know this one, I think. Screw it. Let's do it all, just in case. Give for a label so that we know what it does. Create a variable called angular speed outside of the process. Okay. Probably didn't need to do this. But I'm sort of like, part of me is like, just do it all. Even if you don't need to. Because a little bit of practice will be handy nonetheless. All right, do I need to do anything else? Create a variable outside a process, allows us to use other functions, and replace for with angular speed. Also, it doesn't take that long to do these. All right, the next one was more interesting because it was like, we will create a scope error for you and you can fix it. Something wrong in the code here. Can you see what it is? Yes, I can see what it is. Angular speed is an in-scope variable and it won't be able to be changed by this other function. That's my guess. Let's see how good the error message is. The identify angular speed isn't declared in the current scope. That's a nice one. That's a good, like, just this final bit of the error message saying in the current scope. It's a hint that if it does exist somewhere, it's not in this scope. Halogen saying, surely we do it all so we can appreciate all the effort that went into this tutorial. Yeah. Part of it is like, doing it just because it's so good. I actually already skipped bits. I apologize. I've skipped some bits earlier because they looked like things I already knew. But I'm going to do a lot of it because it's just remarkably well put together. Don't tell anyone, but like, this is like, learn to code here. It's so easy. Although it's very specific because the learn to code that you're getting here is whatchamacallit, like very game specific. This idea of a process and a delta time and stuff like that might be something that you teach someone really, really early if they're going to go into real-time game design. But if you're teaching someone just general programming, you wouldn't talk about this at all. You'd only talk about this in a specific games course or something like that. Okay, so isn't in that scope, so I'm going to assume that the plan was to have the out of scope variable, the global variable. Okay. I do like this auto testing here. I wonder. Well, you know what I want to do now that I'm saying how much I appreciate the tutorial. I want to see what happens if you fail some tests and not others. So I'm just going to change that to 6, and it should be incorrect on some of them, but some of them correct. Okay, good. This is a really nice kind of auto testing thing because it immediately tells you, all right, you've done some things wrong, but other things right. So some of these things are no problem at all. So let's go that to 4. And let's See if it's annoyed about me renaming it. Ha ha ha. Okay, if I don't give it the name that they wanted, they can't find it. I assume the auto tests are analyzing the code, potentially analyzing the code, not analyzing the compiled code to see the execution, but they're analyzing it pre-interpreter, and they're like, this is the wrong name. Fun to poke. Fun to poke at what they're doing. I just think you can super imagine those checks being implemented in a compiler interpreter way. Yeah. So what I noticed before, which was really cool, was some of the other ones which had delta time and stuff like that, they were waiting. So I think what they were probably doing is measuring the angle of the object after like 3 seconds, and then saying, is it within a particular window? Because over 2 seconds, if you don't use delta time correctly, you're going to get off angle. But if it kind of like exactly at 2 seconds hits very close to vertical again, then they can say, yeah, we're pretty sure you used delta time properly. Okay, let's just make sure we get all green ticks on the board again before moving on. Okay, good. Okay, previous lessons we decreased and increased characters' health, but there was no limit to how much health they could have. Obviously, this is one I skipped because I don't remember this. But minus equals and plus equals and stuff is something that I did in one of the previous ones. So that's all good. As a result, a player could increase their character's health indefinitely, which we do not want. I like that the bar goes beyond. We can keep healing. Yes. So healthy. Thousands of health. I love how it's doing a little salute as well. It's very cute. Okay. What happens to health when we damage our character? Suppose the character has 100 health. What would the value of health be if we called take damage 25 5 times? So 5 times 25, 125. Our health's probably going to be able to go into negative if there's nothing else controlling it. Yep. Okay. We can use conditions to run actions selectively. Oh, right. This is their way of setting up what an if-else statement is. Video games rely on other computer programs are full of conditions. Or video games and other computer programs are full of conditions. Yes. If game input largely relies on conditions, if the player presses a button on the gamepad, the character jumps. Yeah. Okay, good. When the computer checks a condition, this is called to evaluate a condition. All conditions evaluate to either true or false. Good. Good. Okay. I've seen this before, right? Didn't we have an if statement earlier? Can't remember. Anyway, if health is greater than 100, set health to 100. Yeah. These are known things. So we're clamping this value to 100. Comparison line greater than. Okay. I'm going to go fast over this bit because it's basic maths. Right. If health above 100 equals 100. So you can't overheal now. Greater, less than, equal, not equal. So it's all a Boolean comparison stuff. Here's how we might use these in if statements. If your health is greater than 100, what is pass? That's interesting. Oh, haha, great. What does pass do in the code? All right. So this is just an example. Pass says I am here in the indent. The scope exists, but we don't have any code. When you don't know what to write yet, you can just pass keyword as a placeholder. Godot won't give any errors. That's a Python thing, is it? Ah, okay. If there was nothing below the if lines, Godot would give us an expected an indented block here. Okay. Which of these statements are true? 1 is not equal to 3. 3 is less than 1. 2 is equal to 1. 3 is greater than 1. 2 is less than 3. I feel like I had a slide in 1511 that had this stuff in it, and it had the same kind of teaching. If keyword comes with complementary else keyword. So if you don't run the if, you run the else instead. Speed 120. If it's less than 100, slow, otherwise fast. Ooh, very good. I didn't realize this was allowing you to step through. Or maybe none of them stepped through before because there was no point seeing where the code went. So this shows you that you don't go into this one, you go into this one. Yeah. Cool. All right. Oh, debugger, so they're showing state as well. This is all just starting to get enough information for you to really see what's going on. So this is cool. They're actually going through a step through debugging here as well, which is good because that's the kind of thing that will be helpful for testing your code later. Okay, else block will run whenever the condition above isn't met. We'll use conditions to improve the way our character's health changes so it has limits. Sorry, I just like messages from someone on Discord, but it was nothing to do with this stream. Okay, let's do some practice. Goals. This series of if statements is all wrong. Or change the comparison so each comparison matches the instruction below it. If health is less than 5, health is greater than 5. Okay, if health is greater than 5, health is greater than 5. If 1 is greater than health, that's a weird way to... 1 is less than health. If health is less than health, health is equal to health. I mean, this is always going to print out, right? Health is not equal to 7. I guess they're just checking whether you can do the Boolean mathematical operations. Oh, I should have scrolled down to the tests. All right, tests look fine. Okay, can create if statements. That's good. We have a heal function that adds an amount to the character's health. Add to the function so the character's health is never greater than 80. Okay, so if... Oh, this is funny, right? Because while this has been going on, I haven't actually learnt what the syntax is. Like, while I was reading all that, I go, yep. I didn't actually just go, okay, where are the brackets and stuff? Okay, but we'll see. I think it's worth me just kind of doing it. And then if I'm incorrect, I will fix it. So if it goes above 80, set it to 80. I don't need brackets. Okay, watch. I want to see them show me. Okay. Let's stay for a moment. So we don't need brackets because this is a single thing. I assume that if I was going to put brackets there, it would be to assign kind of priority to certain parts of the equation. All right, that worked. Preventing health from going below 0. Function take damage of a certain amount. When the robot takes damage, its health can be negative. We want to display the health number on screen, like in JRPGs. We don't want negative numbers. We want to stop at 0 instead. Calling the function should reduce health by amount. If health goes below 0, set it to 0 again. Okay, cool. I assume that somewhere else in this code someone has defined health, because I don't have a variable declaration for health, so just going to assume that that's okay. Health minus equals amount. I keep reaching for the semicolon. It's such a strong instinct. If health less than 0, needs a colon. Health equals 0. All right, that should be it. Cool. Miss Manga saying, but they can be, about the brackets, they can be there if I need. Lets you put the if statement across multiple lines. Yeah, right. So if I need multiple tests, I can put them in brackets so that the line break doesn't cause some kind of issues. Because it's going to count as a different instruction if it's on another line. Okay. Multiplying. Want to increase. Robot's health has always been 0 and 100, but as it fights, we want to increase its strength and toughness. Character levels up, they might deal more damage, etc. Define a level variable to keep track of the level. Call the level up function. Okay. Level up function changes the level. Could have a range of variables that could increase when it levels up. Health, max health, power, and defense. Okay, so we might be doing some kind of multiplication by level for our stats. We're just going to increase the robot's max health. Max health, maximum the robot's health can be. Change our heal function to use the variable max health. So, health plus equals amount. If we go past max health, we end up in max health. Okay. And then when we level up, we go up a level and our max health goes up by 5. Graphed it. Oh, look at that. A little animation of the graph getting drawn as well. So every time you go up a level, the maximum health goes up. Cool, cool. We're going to feeling more and more power as the robot levels up. We graph like this. Haha. We're going to get like a linear and then like a quadratic or an exponential. Yep. Okay. Growth is exponential. With each level, more max health is added than the previous level up. To get the exponential growth, multiply max health by an amount greater than 1 each time the robot levels up. Multiply with a star. Level, power. Calculate damage. Damage is equal to power times level. That should be 15. We can use multiplies equals. Yes. Damage is equal to power times level. Power times level is 15. Damage is doubled. It should be 30. Okay. Level up our robot and add exponential growth to max health. Max health times equals 1.1. Right, so we're just multiplying our health by 1.1 each time. Right, practicing exponential growth. Level up function, increase level by 1, max health by 10%. Multiplies 10%, so it's 1 by 1.1. Oh, you can see it leveling up over here. Can you see that? You can. I was just like wondering if my face is blocking it, but should be okay. There's not much stuff up in that top corner. Okay. So we leveled up and we are at 121. So it's doing... Wait, 121? Oh yeah, 110 plus 11. Yeah. It's like, do I have a basic maths problem? Okay. When our robot's levels 3 or more, we want to take a lot less damage. Add to the take damage function so the following happens. If the robot's level is greater than 2, reduce the damage amount by 50%. Okay, if level greater than 2, amount multiplied by 0.5. I wonder if that's okay. Yeah, that variable is the incoming damage. And if you're greater than level 2, you halve the incoming damage. The robot's level 3, an enemy is going to attack 10 damage. This damage should reduce to 5. Okay, so we should see this go to 95. Yep, there we go. Beautiful. Ooh, 2D vectors. Yay, we're into vectors. I mean, they're kind of just coordinates, but you know. Suppose we want to increase the size of the robot when it levels up. As you may recall, we can do this by using the following code. Scale by X and Y. Yes. What are vectors? Haha. Quantity with a magnitude and a direction. For example, a force applied to some object, the velocity, speed, and direction of a character, and so on. Yeah. Often represent this quantity with an arrow. That's good. 2D vectors are a common value type named vector2. All right, that's fairly normal. Seen that kind of thing before. I like this, like, the sheer amount of trouble they've gone to for all of these interactive little bits and pieces in the tutorial. Like, they didn't have to do this. They could have just drawn a picture. But having this, like, actually interactable is really nice. Ooh. That's so funny. So it's 8:45 p.m. at the moment. And my alarm just went off on my phone. Which means that if I hadn't woken up this morning for the 9 a.m. that I had, I wouldn't have, because I set my alarm for 8:45 p.m. instead of a.m. Well done, well done. Lucky I got away with that. I think I just got myself out of bed at 8:30 this morning anyway, which is quite rare for me. I am not a daytime person generally. Okay, so far you've come across two variables in this course which are vectors. Which are they? I don't know. I assume speed is going to be a value. Scale might be in X and Y. Position might be in X and Y. So these would be 2D vectors. Health wouldn't be. I guess health and speed wouldn't be, because it's speed, not velocity. But I don't remember all the things I've come across in the course, so we'll see. Okay, vectors are great for games. Yes, vectors are super useful in games. They allow you to represent a character. I love how, like, I'm reading with the cursor and the little turtles following me around. Very cute. They allow you to represent characters' movement, speed and direction, calculate the distance to a target, and more with little code. Yep. Take this total AI below. Well, it's a bit stretch calling this AI, but you know. You've probably seen games where enemies move like this. Done with just 7 lines of pure vector calculation code. Yes. The code is a bit too difficult for now. Oh, come on. It's not that hard. Anyway. This total gives you a glimpse of what 2D vectors can do for you and your game projects. Just mesmerized by the mouse following turtle. Okay. Scale the robot again, this time by adding to it directly using a vector 2. Following code has the same effect as the previous example. So, adding 1/5 to its size? We can keep going. Rawr. Okay, I stopped there. Notice how we use parentheses and 2 arguments inside parentheses, just like other function calls. So, vector 2 is a function. I mean, they've cut off the edge of the code here, but we get where we're going. I guess they're talking about the function, the constructor being the same as... Oh, I should just read. They're about to... I like this. Everywhere my brain goes with the way I'm thinking about their tutorial, they go there too. So I guess another reason why I like this is we think the same way. We call this a constructor function call. You can think of it as a special kind of function that creates a particular type of value. Good. Code vector 2 there constructs a new vector 2 with its x value set to 0.2 and y value set to 0.2. And I assume the result of this is the vector itself, so you can assign it to something. Add and subtract vectors to position, because position is a vector. If we want to make a robot move to a new relative position, we'd add a vector 2 to its position. Right, so I assume that both of these numbers are positive. I mean, you can see that. The only issue they've had so far is that this text window is not big enough. I wonder if, wait, why is that not? Is it Control or Alt? I'm going to check my zoom level. 100%? Oh, okay. So it's not my fault. I haven't zoomed text by accident. Made it too big. So one tiny nitpick I will have with their otherwise amazing tutorial is that it will allow the text to go off the edge of the screen a little. Okay. How would you move the robot 50 pixels to the left? Um, position dot x minus, you can't take a number, multiply it by a vector. Position vector minus a vector that's 50 long in x. Right, so we're getting this kind of hierarchy levels of things. It's like you can't do a minus you can't minus a vector from a variable. You got to minus a vector to a vector. Okay, let's do some vector stuff. Add a line code level up function to increase the scale of the robot. Okay, again, because they have not actually declared any of these variables, we're just assuming that we have the right type of variables. So scaling is multiplying by a new vector 2. I don't think multiplying is the right thing here, is it? Because they're saying increase the scale of the robot by that amount. So it's increased by a static amount, not multiply it by 20% each time. Yeah. So it's just scaling up by exactly 0.2 each time, not multiplying by 0.2. Because I looked at that with the multiplication, the 0.2, and was like, that's going to shrink it. Robot's level has increased a lot, so has its size. Let's fix this by resetting the robot's scale and position values. Create a function named resetRobot. I do like that, previous lessons, like they're not going to go write exactly this to declare the function. So it's a bit of like, please remember what you did previously and make use of it. Okay, create the function that sets the scale and position of the robot. X and Y subvariables of the robot's scale need to be 1. Okay. Do we just vector it? This is a question of like, okay, how much memory are you using? How fast are you going? This could be the slowest possible way to do this. So it might be... These two lines might be significantly faster than this. Because when you think about it, this is going through a constructor, it's building a whole new vector, and then just copying its values into this one. It's more memory intensive as well. So this could be a better way of doing it in terms of running efficiency. And it's not that hard to read either. Actually, this one's possibly even harder to read than this one. Because this one really explicitly has the X and the Y. Let's go for this. I mean, I'm totally nitpicking here, but like, what if you're resetting 10,000 robots at once and you want to fit that within one frame? Then every tiny bit of work you do actually does make a difference. Okay. X and Y subvariables of the robot scale need to be 1. Robot's position needs to be vector 2. Oh, okay. They're being specific here, so maybe they really want this one to be the vector and this one to be the subvariables, because they've set it in that way. Make sure to use vectors when dealing with scale and position. Oh, interesting. Interesting. Let's run this and see if they get annoyed with me not using a vector for one of these. Oh. Reset. Oh, right. Syntax. Okay. Oh. Use vector 2 to reset robot. Okay. So I went and optimized something in a way that's not necessary and wasn't good for the way that they wanted us to learn how to use vectors. Oh, hang on a second. Can you hear another voice in the background? I think you might be able to. Let me just like shut a door so my partner can talk to people without it going on stream. 1 second. I'm back. Oh, Zero said you can't actually hear the other voice. Okay, so it's probably not a problem. But in case her voice actually does go in, and like, who knows? It'd be really funny actually if she like was in the middle of a conversation and then doxed us or something like that. Unlikely to happen, but probably better I don't actually put her on the stream, like without her consent. Okay. So we're resetting the scale using a vector, and they said 1.0. Right. Okay, good. They want us to use the vectors. Okay, while loops. This is very interesting, the order that they're teaching things. Is that where did I start? I would have started with something like variables and then gone into loops and then gone into functions later. They went into functions first, then into variables, and now into loops. And I think when it comes down to it, you're going to hit all of these so early and they don't really all work until they're all together, in a sense. Although functions you really could do later if you wanted to. Because functions is just about naming code and moving it away, as opposed to understanding what code instructions do. But it seems like you'd have all of these concepts soon enough to not necessarily need to worry too much about the order. I mean, I say that now, but like when I was teaching like basic fundamentals, we would be constantly be having discussions about which things should go in which order, what was going to be the easiest path for people to eventually understand all the concepts. So right now I'm just like, oh, it's no big deal, you'll get it all eventually. But back when it was like, delivering to like 1,000 people, I'm just like, okay, anything that makes this a tiny bit easier is like, that's like 20 or 30 people that are going to get it that wouldn't get it otherwise. So it's worth having that discussion. So kind of interesting. And I think this one's working quite well, even though it goes in a completely different order than what I would have done. In the back of my head, I'm like, every time I taught 1511, I should have just swapped concepts around and then seen how people did with them. Like, that's a little cruel. You're all experiments. Okay, let's get back into it. You can use functions. Now we will do loops. Our robot can move to neighboring cells by changing a vector2 variable named cell. It represents the current cell the robot is in. When we increase X, it moves to the right. Note that we delay the robot's movement in the app to help you visualize how it moves. Following code would normally move the robot instantly. Right. So it's calling this multiple times. Move to end. Diagonally by plus equal. Oh, yeah, right. It's not moving it. Well, it's only moving it specifically twice. And this one will move it diagonally twice. Oh, that's why I said they're delaying the movement. Otherwise, you would not see the result of the first one because it would be too quick. Okay, the above code works for a predefined board size vector3, but the move to end function wouldn't work if the size of the board was different. Oh, if you want to go to a larger board, we can't just keep typing in lines of code. Excuse me, we might have to loop it. Using while loops to repeat code. Okay, while number is less than 4, print the number plus equals 1. All right, we know this. We know loops. So this is very, very similar to the 1511 avoidance of for loops until people understand code, because the variable declaration is outside, so it's like it's obvious what a variable declaration is. The while syntax is exactly the same as an if statement, so people can use it, and then the stuff inside the indentation is the same as like an if statement or a function. So that was a nice thing about using while loops, and it seems to be working here as well. Okay. Function run, set a number to 0, While it's less than 4, keep printing it out and adding 1 to it. So we should see this go 0, 1, 2, 3. Yeah. Debugger number ends up at 4. Okay, so we could debug that if we want to. Okay, let's apply this to the move to end. You keep moving it until, well, board size X is, oh, while the cell is less than the board size minus 1. And we can do this for much bigger boards. And it will keep going until size minus 1. Beautiful. While loops can cause issues, yes. Does anyone remember when I did this? When we were learning about memory allocation and memory leaks? And I think I did it on VLab, and I built up to like 4 gigs of memory used in a tiny little C program that was just allocating a single integer size piece of memory and then just looping and just kept allocating and never deallocating it. So similar kind of thing here. What would happen if the computer tried to run the code above? Number equals 0, while number is less than 10, draw a square. It's not iterating, so it goes forever. All right. When to use while loops? At first, you will not need them often. Even the code we show here has more efficient alternatives. Also, there is a safer kind of loop, for loops, which we'll look at in the next lesson. Oh, okay, cool. So they're going to show them immediately. While loops have an important intermediate to advanced level uses, so you at least need to know they exist and how to use them. Yes, yes. Games run in a loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. Alright, just keep looping forever. Other good uses? Reading and processing a file where you don't know how long it's going to be. Processing a constant stream. Yes. Reading code and converting it into instructions the computer understands. Basically, your compiler is just a while loop. Various intermediate to advanced level algorithms like finding paths around a map for AI. Yeah, totally. I like this. Like, you know, they're breaking it down into like all these different things where looping is kind of inherently useful, but specifically not for loops. So all these are open-ended things where you don't know how long they're going to go for. All right, practice while loops. So obviously we're going to go into this and we will immediately implement a Dijkstra's shortest path algorithm over a over a graph. Probably not. Okay. Robot has decided to stand on the top of the board. Complete the move to bottom function so the robot moves to the bottom of the board. Board size is determined by the vector2 board size. Robot's current cell's 2, 0. Okay. So if we don't necessarily take into account the position, we're still going to need to be able to keep moving until we reach the bottom. So while how do we, what's the variable name for our position? Cell? Cell position of the robot on the board. Okay. While the Y variable is less than, what was it called? Board size? Yeah. Oops. I still have those issues with, oh no. My Z key is very shaky, so it's doing a lot of multi-presses there. I think I might have to take, I had this problem last week, right? But I just haven't typed very much on this keyboard, because when I'm typing, I'm usually at work. On this keyboard, I'm usually gaming. But yeah, that Z is a problem. We'll figure that out later. Okay, board size Y is the total number of cells, but since there's a 0, we take a -1. I don't know if I need brackets for this, but I'm going to assume that I do. Okay, while cell Y is less than board size Y -1, increment cell Y, and that should take us down there. Robot gets the bottom of the board, use while loop. Alright, let's see if that worked. Oh, wait, what have I done? Error passing expression. Misplaced new line at line 4, column 0. Line 4, you say? Okay. I didn't see there being a, like a termination on the while loop. Wait, should there not have been a colon? I thought the while loop had a colon. Maybe they just wanted this so that there's something in the function? Nope. Misplaced new line. Explain. Is this error when you wrote something that is syntactically invalid or you're missing something to complete this line or previous lines of code? You need to be extremely precise when you write code. Yeah. This error can appear after the line causing it. Okay. Obviously, I have some syntax incorrect here. Was the while loop? Let's have a look at some while loop code. While condition, colon, do stuff. All right. I should have opened that in another window. Now I have no code, but that's okay. It wasn't that hard to write. Okay, while condition. So cell.y is less than what was it? Board size? Board underscore size. And then there was a colon. Oh, wait. Did they have plus plus? Maybe they don't have plus plus. Yeah, that's it. Making assumptions. I love how I had no inkling of what I'd done wrong, and I was checking all these other bits of the syntax then. Okay, for loops. For number in range. Oh, okay, so these aren't the, Oh, yet another tick in the Python similarities. Python also doesn't have plus plus. One day they will release a P++, and it will be Python just with a plus plus iterator and nothing else. Okay. For number in range, 3. I assume that will do 0, 1, 2, 3. The loop below will change the cell 3 times. Okay. So that in range, that means a specific number. This is the exact number of times something happens. What list numbers would range 6 create? Oh, this is good to know. All right. Let's make sure we understand what range is, because this is a custom function. Godot has the helper function range. Calling range n creates a list of numbers from 0 to n minus 1. Okay, so the n is the number of things it creates starting at 0. So print 6 should do 0 through to 5. Okay. This is good. And again, this is like the difference between this and Lua being an option. Was that it's good to start at 0, but also if you're going to call a range, you get that number of values out of it. Okay, how for loops work. For all the numbers in this range. So this is the same as in C, just going a for loop where int I equals 0, I is less than 3, and I++, but it's just kind of easy to read because most of these words in here are English words, so it's kind of easy to read it as a sentence. Okay, so it prints out 0, 1, and 2 for range 3. Okay. Oh, we've got arrays. Wait, did we have arrays? Each item in the list 0, 1, 2, Godot sets a number to the item, then executes the code in the for loop. Oh, wow. For element in this, go through this, pick out the elements. All right. we print the value of the temporary variable we created. So they're being specific and saying, if you're going to do this, that array is not going to exist outside this scope, but you can use it while the for loop's running. Okay. If we do this, we create an array and an element, and the element is array 0, you print it, and then 1, print it to, oh, that's pretty bad, but I assume what they're going to do after they've done the 0, 1, and 2 is to say, we could do this with a for loop. Yes. Using a for loop instead of a while loop. Move to end for the number in range that plus equals 1. Yeah, so this is not knowing the... Actually, no. Both have to know the board size. So this is not knowing how many steps you're going to take. This is the range will tell you how many steps you're going to take. Although, I can't say I like this code. Because what if you didn't start at 0? You're making a relative change to a position, assuming that it had a fixed value at the beginning. Because this will move you 1 based on the range of the number of things. So yeah, it's not entirely correct there. Okay, anyway. I was just saying, theory about them teaching functions first probably extends naturally from wanting to explain their equivalent to the main function early on, rather than having you fill it out without explaining it. Yeah. Because I remember when we had the main function, we were just like, look, here's some stuff, please ignore it. You'll learn later what it means. Just ignore it. Just copy paste this thing at the start of every program you write, and then learn these things. And then like a month later, it's like, okay, here's a function, and you already know functions because we actually had one this whole time. So it is nice that they're not leaving anything on the table that you haven't learned. So there's a slight issue with this for loop, being that your starting position has to be 0 for this thing to work. I mean, unless you can go beyond the cells and get automatically put back in the right place, I'm not sure. But they are demonstrating that no matter how much space you have to do, whatever the number is, you'll move to the end and stop moving. Okay, let's practice some for loops. Because I totally, like, memorized that syntax a second ago, so I should be fine. Okay, robot has decided to stand on top of the board. Use the for loop in the move to bottom function to have it move to the bottom of the board. Okay. For... Great, I've already forgotten what it was. Oh, was it for variable in range? For y in range... what is it called? Board size. Did this have a colon? We're just going to do it and see. Does that even matter? Because I'm not using that variable, am I? Sums out how much Python experience you have, I think. Yeah, right? So this is like normal Python, isn't it? And it's the fact that I don't know the Python syntax for a for loop. I might be getting this wrong. Let's see. Use the for loop. Okay. Oh no, I can't right click on it. Oh, screw it. Let's just go back so that I actually read the syntax. For number in range this. Yeah. So we've got a dummy variable that we're ignoring. Oh, it was -1. Because board size is the number of elements, but since we're in one already, we have to move -1 times. Okay. Okay. For y in range, board size. I think that's it, right? Board size y -1. Cell.y plus equals 1. In Python, you can use underscore to say you're not using the variable. Ah. Let's see what that does. Oh, no. Identifier expected after 4. So, the underscore is certainly doing something here, but it's not allowing that. Y feels like a bad variable name to use because there's all these other Ys, but it should be okay because it's just a floating variable that we're never using. Oh, expected colon. All my mistakes are syntax. All right, we have moved. Okay, what's the next one? Improving code with a for loop. Use a for loop to remove the duplicate code in the run function. In this practice, we revisit the total and drone rectangles. With our new knowledge of for loops, we can condense this code to take up less space and make it easier to modify. The turtle should draw 3 squares in a horizontal line. The squares should be 100 pixels apart. So we did this with functions previously, but now we're going to do it with loops. Do we need to use a for loop? The code's exactly the same. X. There's 3 of them, so we go range 3. Oops. I should do that. Oh, colon. Look, I just reprogrammed my brain to stop typing semicolons, and now I'm going to forget to type colons. Nice. Okay, creating arrays. All right, so we did see this before. Ooh, look. If you step through, it actually shows you that this number is getting assigned here. They did put a lot of effort into this. Oh, it shows you that this one is the one being accessed. And that one. Wow, that's cool. I'm glad. I was going to skip over that actually because I was like, yeah, I know how to do that. But it was nice to actually step through the debugger and see how well they did that. And I wonder if that's a generic function of what they're doing, or like what sometimes happens is it's like a highly explicit, this is the, this is a specific example. Although hovering over the variable and getting a value out of it makes me feel like this is actually a debugger, which is nice. Okay, code still works the same. Created a for loop. We also create a local variable to which the loop assigns 1 value per iteration. Yes, good. And you can name it anything you want. Okay. Unwrap the for loop. We get the following code, same behavior. Yeah. Syntax of arrays. Value, commas, spaces. Comma separated values. We might not need those spaces. Couple of valid arrays. An array of vectors. Wait. Notice how you can mix values, how they don't need to follow one another. Okay. Non-type specific arrays. Any variable fits in them. So we got a vector, and 2 numbers. Arrays themselves are just a value type. Just like numbers or vector2, we can assign arrays to variables to reaccess them later. Okay, variable, array name, and then the stuff. First, let's see when. I love this. Let's see when you'd use an array. In computer programming, we use arrays all the time. All right. Question has been answered. When do you use an array? All the time. Oh, there's a non-Python bit in here. I wonder if it's the multi-types. Yeah. So it looks like their var is a JavaScripty var rather than a Python-y var. Okay, when you use arrays, yeah, almost. Use them when you need to store a list of things. Yes, good. Players party, inventory. This is so cool because these are like the examples I used to teach with. Do like a little array for an inventory kind of thing. Use arrays to follow a path. Okay. So the path is going to be like go right or go down or go right or something. Wants to follow a robot, but there are rocks in the way. How can we tell it where to walk to reach the robot? With an array. So 1 to the right. 2 to the... Wait. 1 to the right, and then 2 to the right, you run into the rock. Anyway, let's see what they're... Oh no. Each value in the array is a cell the turtle needs to walk through. Okay, so those are positions. I thought that these were like, take 2 steps to the right. But you probably don't want to do that because you want to keep it to 1 step. So step to this, then to this, then to this. Right. So these are just explicit positions. All right. Let's see how we can use arrays to store player inventories or design attack combos. Ooh. We're getting gamier as we go, right? Turtle wants to meet the robot, though it cannot find it on its own. Fill in the turtle path array with vector 2 coordinates indicating where the turtle should move to avoid the obstacles and arrive safely at the robot. Turtle can move up, down, left, or right, cannot move diagonally. We recommend copying and pasting to fill the array with comma-separated vector 2 values quickly. Okay, so we'll do the first one. Vector 2, oh, you know what? Just to be contrary, I'm going to go down first instead of going to the right first. And we'll comma and space, and then that way we can just copy-paste this. Okay, 1, 2, 3, 4, 5, 6, 7, 8 steps. 2, 3, 4, 5, 6, 7, 8 steps. So the first one I went down, next one I'll go across. I guess I could just go all the way across. And then I stay at 5 and go to 2 and 3 in the y-axis. All right, that should do it. Got to get rid of that. Haha. We've defeated it. Okay. Ooh, in this tactical game, the player and computer can select multiple units at once. We're in an RTS. You need to call the select units function and pass it an array of the vector 2 coordinates to know which units to select. Each vector 2 in the array represents a cell with a unit. You can pass arrays in function calls as arguments, as an array is a value type the computer recognizes. You can pass the whole array as a single function argument. Cool. Select all units on the board by passing the correct array to the select units function. Okay, so we need the coordinates of each of these. So this one's at 1, 0. I wonder if we have to create it. Like, you can't just go... You can't just do this. That doesn't instantiate it without it being explicitly a vector. Let's test it and find out. 0, 3. What's this one? Oh, no, 5, 1. I'm just going to assume it's going to throw an error, but we will find out. Okay, this is 4, 2. So this one's declaring as a vector. These, I'm attempting an implicit declaration as a vector and seeing what it does. Nope. Expected close bracket, so it doesn't like this. All right, we tried. It's worth having a look. I mean, kind of knew that was going to happen because at no point did they say that there's a shorthand for a vector. Oh, wait. Oh. The method vector isn't declared in the current class. Oh, wait. Vector, not vector2. All right, cool. I love it. Everything's just like syntax error. I'm just making like a long string of syntax errors. Okay, looping over arrays. Okay, we're getting down to like the whole. This is like, where we're approaching first year student level here, because once we can loop over arrays, you're pretty close to getting a passing mark in 1511. Okay, range function produced. Oh, I mean, you've got to do memory management as well, but you know it's more than that. But still, okay. Print the numbers. Loop over the array. Print the numbers. Create the array outside. Print the numbers. Okay, what will this code print if I have a numbers with 0, 1, and 2? For every number in numbers, print that number. So it should be 0, 1, and 2. Make the turtle walk with a loop. In the previous lesson, you made a turtle walk along a path by writing vector2 coordinates in an array. It's a for loop that makes a turtle walk along the path. The loop works like this. For each coordinate in the array, it moves the turtle once to that cell. Okay. Oh, I assumed we were doing this, but maybe they're just talking about it. For each coordinate in the array named selected units, we check if there's a unit in that cell. If so, we select it. Selected units, go through the cells, and then add that cell to the list of selected units. The condition, the in keyword, allows you to check if a value exists in an array. If cell is in units. Cool, all right. Append adds a new value at the end of an array. Yeah, append. When functions exist only on a specific value type, you write a dot after the value to call the function on it. Right. Arrays have an append. Append is not a function on its own. Cool. All right, let's see how we go here. Here's the path. Has AI pathfinding algorithm. I just got to slow down. The AI pathfinding algorithm provided a path for the robot to move to the right edge of the grid. Your task is to use a for loop to make the robot move. To move the robot, call its move_to function, like so, robot.move_to. Okay, so they're starting to introduce the fact that objects have specific functions. So objects have member functions in a sense. Okay. Are we using a loop? This isn't process, is it? So this is all happening in one thing. Okay, so for P in path. Wait, it's called robot path. Desperately want to know what it does if you give it a move to a cell that isn't adjacent to its current position. Yes. All right. Move to its final destination. What is it called? Robot.move_to. Oh, wait, I copied that, didn't I? All right, let's see what it does. Yes. Code uses move_to, so we got that right. Robot moves along the blue path. We got wrong, so we didn't go along the path it said. Okay. Let's do that now. So for P in robot path, actually I'm going to name that better than P. Step in robot path. Move to wait. Step. I forgot what this is for. Okay, so this is going to extract the steps from that and move to them. Nice. It's always nice when I think they did set this up specifically that the code you actually have to write to loop through a vector is very, very small. And so I think they set this up specifically to be like, no, you don't actually have to write that many code to do what is quite complex compared to the things you've done previously. Okay, Algin saying, okay, the cell by cell is more animation-y then, huh? I guess so. It is definitely setting us up for like what you'd think of as waypoint traversal, which is a good thing, because if you have the same kind of thing, if you have an AI process that does a pathing algorithm, you don't want to leave the path, because the pathing algorithm is actually putting you on, say, the correct bit of the footpath that the NPC should be walking on. Or there's a road in between two fields and you want to stay on that road rather than randomly walking off into the grass. Going explicitly from one waypoint to the next is a way to do that. Okay, we want to draw many rectangles, something surprisingly common in games. Very good. I love these little asides for like, these are the annoying things we have to do. However, writing this code by hand can get tedious. Instead, you could store the size of your shapes in arrays and use a loop to draw them all in batches. So we've got sizes only and not positions, but we're going to draw these in a batch. Use the for loop to draw every rectangle in the rectangle sizes array with the draw rectangle function. Okay, so for R in rectangle sizes, rectangles shouldn't overlap or cross each other. To avoid that, you'll need to call the jump function. So we're arbitrarily choosing where to jump, so long as it's not inside the rectangle that we just created. Okay, so first of all, we draw the rectangle. And draw a rectangle is taking a length and a height. So I don't think that we'll be able to just pass a vector into this. So we're going to probably have to do r.x and r.y. For the rectangle, should draw the rectangle, and then we're going to jump. Is jump explicit or relative? Offsets the turtle's position by the given x and y amounts of pixels. Okay, so draw a rectangle, we're going to assume that the turtle moves in a clockwise. Oh, this is not clockwise to you. Anyway, just for me, it's a clockwise circle, so it's going to end up on the top left corner. And so we want it to jump, I guess, to the right. Did they say? They just said they shouldn't overlap or cross each other. Okay. Oops. R.x plus 10. I don't know how far apart these need to be, so I'm just going to offset them by 10 pixels. Jump. Offsets by the given amounts. Okay, let's just do a 0 in the y. So it's going to hop over the rectangle it just drew from the left to right and go a little further. Let's see if this works. So we do this, we jump a little further. I was very close there. I probably should have given it more space. I think they still think I'm correct though. So even though those knobs are overlapping, the abstract ideal form of the rectangle, which is just the lines, are not overlapping. Okay, strings. All right, so we have word variables now. I wonder if they're going to show us text output stuff. Oh, they kind of have already because you can print stuff. But whether you can attach text to different locations on the screen and stuff, probably not, I assume. Okay, strings value type that holds text. For example, yes, that's a string. Quotation marks differentiate strings from other value types and function names. Ooh. My apologies. I'm a little tired this evening. I'm gonna hold out though, because I usually stream from 8 to 10. So I'm gonna go all the way to 10, and I'm gonna keep doing this tutorial until I get to the end of it. Okay. You can make a variable name, which is a string, and then you can print it out. Cool. And you can print out the individual characters, and the way they print is they separate them all. So, okay. Which of these are strings? That one and this one, because, well, I assume that the one in the double quotes is the character one, not the value, not the numerical value. And that will be the number. Okay, good. Why do we use strings? Every piece of text you see in this app is a string that Godot is displaying for us. Yep. Vector 2s for calculations. Strings come with many helper functions and tricks that we can use. Well, that's good. Sorry, that sounded like a cat for a second there. But there's no cat behind me. Wonder where she is. Did they just reveal they made the tutorial in Godot, or was that established? They did not say that, but they're saying every piece of text you see in this app is a string that Godot is displaying for us. So it does make a lot of sense. When you think about it, why wouldn't they? But I don't think they'd actually said before that each of these windows is literally a Godot kind of executable running, which is kind of cool. It's good to know that it has that capability, and it's so lightweight that you can just run multiple copies of these things in a browser window and it doesn't really mind. Okay. String variables have helper functions. You can use arrays to store strings. Chaining animations. Oh, cool. So you can chain these animations. Jump, damage, damage, jump, level. Cool. All right. Let's use some strings. Currently, a robot has a number stored in the robot name variable. Change robot name variable so it's a string instead. You can give it any name you'd like. Well, we're going to make chicken a robot. What? Oh, sorry. The basics. There's nothing more true in a programmer's life than tripping over the most basic of things when you've got decades of experience. It's like that kind of thing where like you have this idea of like memory where you remember something new and then an old memory just disappears out of your head when you do it. Okay, in this practice we'll chain together animations using an array of strings. You may find such combinations in fighting games. Yes. Robot has the following animation names. Jab, uppercut. Oh, it's really fighting. It's like punches. Populate the combo array with animation names as strings. Then for each animation in the array, call the play animation function to play them. Array should contain 3 values, so the robot makes these 3 attacks. 2 jabs followed by 1 uppercut. Alright, so they're names, so they're just strings. Okay, jab, jab, uppercut. And then we are looping through these and calling play animation. So for punch in combo. Play animation for punch. I think that's all we have to do, right? We've created an array of strings and we're iterating over the array. Ooh, that uppercut. Let's go back and run that again. Punch, punch, pah! It's like a Mario jump. It's huge. Wonder how they handle unknown animation names. Well, let's give them some known animation names and see. Jab, then jump, then uppercut. Oh, the jump is there. It exists. What else did they have? It was like a level up. I don't know if that's how they spelt it. No. Okay. Combo isn't correct. They had something, right? Was it this? Was it this level up? Nope. There was that salute thing that they did. Nope. Well, there was at least one in there that worked. I can't remember what it was. I can't remember the exact string, but there was a level up thing. Maybe it's just level. Level doesn't sound right, though. Oh, it was! It was level! Haha. Okay, so it will play the animations in here. I like how all the code they've got for stuff, they left it there. And we're kind of poking into it, even though we're not supposed to yet. Okay, let's put this back so that it's okay with what I did. And now we've passed the test and we continue. Okay, functions that return a value. Okay, so we've got functions with returns now. So this is printing a number rather than returning the value. And this is rounded health equals round health. So instead of it being they didn't actually show the function. I would have liked to see the function and show how it returns. But I guess we'll see what right, this only has reset. Oh, right. Right, so as I change this number, it changes that number. And it's rounding it. Right. Okay, good, good, good. Yeah, with the animations, how, yeah, it seems they just skip the unknown ones. Okay. Notice how we assign the results in a function call to a variable. Yeah, cool. So we can call a function like round. Oh, round is not even our function. Round appears to be a, because it's in red text. Oh, were the other functions in red text? I don't know. I don't know if that means it's one of their functions or they're not even, syntax highlighted differently, but that's okay. Okay, so the function runs and it assigns its result to a variable. Now we've got lerping, linear interpolation. Calculates and returns a weighted average between two values. It takes three arguments, the two values to average and the value between 0 and 1 to skew the result. In game programming, it's used to animate things moving towards a target with a single line of code. So we lerp from one position to another position at the speed of 2 times delta. It's kind of cool seeing it slow down as it reaches the cursor, because the lerping is a linear interpolation. It should take 2 seconds to get to its target. So if I never stay anywhere longer than 2 seconds, it will never actually reach the cursor. And it's nearly going at its 2 second speed every time I move the cursor. It starts a new linear interpolation. And if I move it somewhere else, it goes to wherever I'm going next. Okay. Every frame, the code calculates a position somewhere between the turtle and the mouse cursor. And lerp function takes care of everything. It's not the most robust approach for smooth movement, as you'll learn in the future, but it's a helpful function nonetheless. Yeah. Write a function that returns a value. You can make your functions return values with using return keyword. In previous lessons, we had characters working on grids, and for those practices, you're working directly with cell coordinates. Well, cell coordinates don't correspond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell's coordinates to a position on the screen in pixels. So this is at 60, so there must be 60 pixels away, there's a corner. 180, 60, 360, 300, 180. Yeah. So we're getting all of the coordinates probably at the top left corner of each of these boxes. Oh, to find the center of any cell on the screen, we need to convert the cell's coordinates to a position on screen in pixels. So it's going to be the center. We use a function. First, it multiplies cell coordinates by the cell's size, which gives us the position of the cell's top left corner on the screen in pixels. Multiply the cell coordinates by the cell size. So are we assuming this is 0, 0, and then this one is like, what was it? 180, 0. It's not even 0. It's actually 60 because it's got the data down there. All right, let's see what it's doing. It's got a cell size. Convert to world coordinates of the cell. Cell multiplied by its size plus its size divided by 2. So, we're getting on the one side, we're returning cell, which is convert to world coordinates, times by the cell size, plus the cell size divided by 2. Not sure exactly what that is doing, but I think it is the idea that linear interpolating is between 2 points, and the higher the number gets, the more you get to 1 point. When it gets to 1, you're at 1 point. If it's at 0, you're at the other. So multiply by one side of it. Adding half on the other end. I'm not 100% sure what this is doing. This isn't necessarily a linear interpolation that I know how to do, but I think it's to do with cell positions. Anyway, let's see what it does, and it's easier to understand. Oh, that's not the same code anyway. Anyway, the return keyword returns the value to the code calling the function. You'll receive the result where you can call the function. What is this doing? Creating a variable for world position. And it's a vector 1, 1. So the position 1, 1 in the world, what we think is 1, 1. So it's just a little bit bottom right of the center or the top left corner, actually has a pixel position. And this is saying it's at 180, 180. Okay. Some functions return values and some do not. You can learn which functions return a value using the documentation panel. All right. There are functions that start with the term void that do not return a value. Okay, so we've got a lot of function naming. So func now means it returns a value and void means it doesn't. Let's find out more about what other terms mean in a couple lessons when we explore value types. For now, let's practice returning values from functions. Okay, so there should be a simple example to get first. Define a function that converts a position on a grid to the screen. Well, that's not grid coordinates. That looks like screen coordinates. Function takes in a vector 2 cell coordinate as an argument. You should return the corresponding vector 2 screen coordinates at the center of the cell. Oh, that's why I had divided by 2 before, because it was dividing by 2 on the width. Okay, so this thing is going to return cell size is that. The cell is the cell coordinate as an argument. It should return the corresponding vector 2 coordinates at the center of the cell. So I'm going to assume that this cell argument is the top left corner. We're going to return a vector 2, which has the center. So cell.x plus equals cell size.x divided by 2. And then the other number is going to be the same thing, but with y's. I don't know how we're going to do with the division here, and I hope that's okay. What this should be doing... Wait, plus equals, is that the right thing to do? I guess if we've been given the top left corner, we should add the half of the cell size value to both of them. So it's probably okay. No, I have made a mistake. Unexpected assign. Convert grid coordinates at line 4, column 1. Wrote something that is syntactically invalid, or you're missing something to complete this line or previous lines of code. I wonder if we need brackets around these two individual objects. Oh, wait. What is this? Okay, so this is one coordinate, and this is the other coordinate. But the plus equals might not be giving us a value. Oh, we're not supposed to move it, are we? So we're making a new value, which is just adding the half of the size of each cell onto that cell. Okay, so maybe this works. Nope. We got 4041, but we expected 4120. So cell y plus cell size y divided by 2. Why would that have gone to 41? When I assume it started at... Did it start at 4040? Okay. Takes a vector 2 cell coordinate as an argument. It should return the corresponding vector 2 screen coordinates at the center of the cell. So the cell is going to be 0, 0. Zero plus half of the cell size is 40. Expected 4120. Oh, it's 0, 1, not 0, 0. So cell y is 1 here. Oh, right. No. I should have been multiplying these by these coordinates. It's just lucky that one was 0. So if the cell size is 80, then the x value is multiply this by the number of pixels of a cell size, and then add half of those number of pixels. So and I should not have 80s in here. These should be cell size. All right, this is getting messy. I have created my first mess, which I'll have to clean up. Okay. cell X, which is the which of these it is, multiplied by cell size, is the offset of moving along the row. And then to get to the center of each one, we add the width of a cell. Oh, I don't think we need to times that by 80 because the width of the cell is already 80. Okay. Oh, this is the thing that I saw before that I was like, I'm not sure about that. Okay, now I'm sure. So we take the 0, 1, 2, 3, 4, etc., and we multiply that by the size of the cell. Let's just delete the Y one for now so we can actually see this. So this is our X. We take the coordinate, multiply it by the number of pixels that it should be. So if it's 1 along, it's 80 pixels along. And if it's 2 along, it's 160 pixels along. So it goes that far along, and it goes a little bit further by half the cell size to get into the center of the cell. I think that's correct. I don't know if there's a nicer way to write this. I assume there probably is. But it should be okay for now. Okay. Nice. Okay, now we are mapping to coordinates. Right. What are we? 956. High school maths. Factor out cell size. Oh yeah, total. Oh, I shouldn't have. Let's go back. Let's go back. Because there should be an easy. Well, I mean, I should be able to copy the thing they did there, but rather than just using the answer. So, what was it? It was cell X multiplied by cell size X plus cell size X divided by 2. So we should be able to pull cell size X out of this. So this is equal to cell size X multiplied by cell X plus half. Is that correct? That seems correct. So that's our X coordinate. So if we do a vector 2 of this, I'm going to put the brackets down here so that I can do the Y. I mean, it's not actually that much nicer. Okay. Cell size X multiplied by the position plus a half. The size of Y multiplied by the position plus a half should get us the center of both of those. It is a tiny bit shorter, yeah. Whether it's more readable or not, I don't know. Because when I read it in the text earlier, I was like, I don't know what they're doing there. But then once I worked it through, and I was like, oh yeah, I see what they're doing. It's not that hard. You're taking the width of a cell in pixels, and then you're taking the position number of the cell, like the index of the cell, and converting it from an index into a pixel. So it should be the index plus half of the width and the height takes us to the center of that cell, and you multiply that by the width. So you could have, if we're here, it's 2 full widths and a half width. So it would be, if we're in cell 2, 2.5 times the width would get us to here. So that should be correct. Yes. Okay, good. It's a little bit shorter, yeah. It's not it's not that much. And also, I'm not sure if you also noticed what that was here. Because they did it differently here. They took the cell multiplication out of it. You're FK, but you got it from me reading it out. Alright. So this one here, I didn't get when I first read it. So it was like cell times cell size plus cell size half. It's the same thing, but it's just going about it a slightly different way. So we move along the cells by the number of pixels we need to go to get the edge of a cell, and then we go half a cell in, and we get the center of it. So it's the same thing once you kind of say it out loud. But when I first read it, I didn't get it. And I think it's because it was like cell and cell size were confusing me, like just the naming. So if it wasn't cell and it was like index and cell size, then I know that this is not a specific cell. This is the index of the cell. It would have been easier to think of the mass then, I think. All right. All right. I think you can tell already that my brain was not super on it today. But I think that was interesting anyway, and we're now like nearly all the way through. Next time we'll go through, do the rest of these, and then hopefully then hop back into, oh, that is bright. It's like when you're coding in dark mode and then you get an all white screen on a very high brightness monitor. I don't know if you can see that on my face. Yeah, it is fully reflecting on my face there. We will then have what I think is a good grasp of GD script, and so we're able to use that in Godot, and then we'll start going through how Godot puts together scenes and nodes, scene tree and stuff, and then we'll actually start using the game engine. The white shirt is you can see the back and forth reflection there, yeah. Okay, so let me into another all white thing. So, what are we at today? 12th of the 5th. We continued learning GD script. It's very Python-y. It seems to be doing things that are intuitively understandable. Still seems like a good prospect for making our game. So I'm just gonna basically keep poking at Godot until it's either does something that makes me think I don't want to use it, or we get to the end of all the tutorials and it's like, all right, you're fully qualified to use Godot now, and I'll be like, all right, well in that case we go ahead and do it. I don't know. The question will be, if it does not do anything that I don't like, and if it's like totally dead on and works, then do I bother testing any other engines? Because part of me is like, oh, why bother? You know, I don't need to test other engines if I think this one's going to be good enough. Because it's not super important. Like, I guess it could be super important long term, but highly likely it's not super important. So just getting going and starting to actually make the game from here on, if this engine is the one, then that might be a nice way to do it. Okay, I will wrap up there, because I'm feeling a little bit tired today, a little bit out of it. So, but we got good stuff done, and we learnt more about GD script, and it seems to be good. It seems to be working. So I think we'll be okay with it. All right. Thank you all for coming along to another Marc on Mondays. Next week I will try to actually plan out the when the stream is going to be earlier. Although it doesn't really matter because we're always on 8 p.m. on Monday, so it's kind of like it's fine. You can find me very easily. So I will see you all next week, same time, same place. We will most likely finish our learning with GD script next week and then move on to actually using the engine and see what it looks like and how it works. See you all soon.